Hello everybody. Today we're talking about the extrema of functions and the end behavior of those functions. So starting off, we're going to start by mentioning how extrema work. Extrema are basically high and low points. If you can imagine a hill or a mountain, those would be high points. A valley or some sort of riverbed would be a low point. So the highest point is simply called a maximum. And a low point is called the minimum. Now, you also have to be concerned about something called a relative max and a relative min. Basically, this happens when there's more than one sort of graph, okay? Now, if you notice, a relative maximum would happen here and here because of all of this area that's above those 2 points. Okay, so those 2 points would be relative maxes, right here and right here. Now, a relative minimum would be like right here and right here because those 2 points are lower than the surrounding points, but if you look at the rest of this arrow, it's continuing forever and ever down there, so it does in fact get lower than those. You're just worried about those 2 points that are directly lower. So maximum has to be the highest point, minimum has to be the lowest point. Relative max and min are according to whether or not they're higher or lower than the surrounding points. So this graph kind of outlines that exact same thing. This is a relative max because of this location up here. This over here, the relative max, is lower than the absolute max over here. Conversely, the relative min is lower than the surrounding points, but it is not lower than this absolute minimum over here. So identifying some of these, this parabola for f of x has a low point right here at 0, -5. Because there's no other points on the graph lower than that, and you notice the arrows continue up away from the minimum, this is considered an absolute minimum. Now on g of x, we have a couple relative extrema. This point right here at -2, 8, -2, 8 would be considered a relative max because it's the highest point. It's where it kind of changes direction there. But it's a relative max because the arrows keep going above that on the other side. Now down here at 0, 4, there is a relative min, a relative minimum, again, because there are points below it, but that's a location where it changes direction. So you're always looking for those like change of direction locations. Sometimes you're going to have to estimate, but most of the time it's going to be pretty well given for you in math. Now for end behavior. End behavior is exactly what it sounds like. You're looking for what the graph is doing as it gets to either end of the function. So you're essentially looking for the arrows. So if you notice the arrows here, as the x value is increasing, okay, so as x is going to positive infinity, okay, so this is meaning as it goes to the right, the arrow is going up. Okay, so we basically have to form some sort of association with right and left for x and up and down for y. So if it's going up as the graph is going right, that means positive infinity. Now, if the graph is going down as x is going left, okay, both of those are negative, down and left are negative. That's why both of these on the left side are negative infinity. Conversely, on this next one, it's kind of flipped. So this graph is working its way down to the right. So as x is going to positive infinity, this time it's going, f of x, the y value, is going to negative infinity. I'm going to be okay with you using y instead of f of x because it might be a little easier to understand. just realize f of x and y are the same thing if you see them in print. Now, both of those functions have an odd degree, meaning the exponent is going to be 1, 3, 5, 7, 9, etc. So on any time the degree is odd, you have to pay attention to that leading coefficient for the actual value of the end behavior. Okay? Now, if you have an even degree, usually, not usually, always, that means the graph is going to be trending in the same direction either way. So, if you notice this first example, the arrows are both going up. That means the degree is even and the leading coefficient is positive. So as x is going either direction, x is going left to negative infinity, x is going right to positive infinity, the y values are both increasing here, okay? They're both going up to positive infinity. Now, the next one, as x is going to the left, negative infinity, f of x is also going to negative infinity, and as x is going to the right, f of x is also going to negative infinity. So, all of the degree stuff, all of the leading coefficient stuff can tell you exactly what's going on. You're just looking for those things and trying to match them up. Okay, something that may help you here. If you have x and you have y, or f of x, x is always right or left. Y is always up or down. Now, right for x is positive infinity, and up for y is also positive infinity. So if you find the direction of the line, so you have to do x and y separately, you can kind of use this simple little chart to kind of identify which direction to, or which extrema, which end behavior, positive infinity or negative infinity, is actually going to match up. Okay, so to use that here, if you notice this first graph, I'm going to worry about the right side first. So on the right side of this graph, x, as x is going to positive infinity, f of x, or y, is going down. Okay, so x is going to the right, that's positive. Y is going down, that is negative infinity. This is an end behavior. Now on the other side of things, as x is going left, meaning negative infinity, y is going up. Okay, so that is positive infinity. So again, right for x is positive, left for x is negative. Y going down means y is negative, y going up is positive. Now this next one's a little tricky. We're usually not going to try to trick you here. This always starts the exact same way. As x trends to positive infinity and as x trends to negative infinity. So we're worried about going right first and going left second. Now because the graph is going to the right, it's staying exactly here at y equals 2. This is the one time in which you get to use an equal sign because it's not increasing, it's constant. So as x is going to infinity, y is just going to equal 2. And as x is going to negative infinity, y is still going to be equal to 2 because again, it's constant, it's unchanging. And that's how end behavior works. I want you to try these two, so pause your video and test them out and then check your answers after I write them down. I'm going to give you a couple of seconds before I go, so make sure you pause. Okay, so again, you always start with as x goes to positive infinity. That means going to the right. And as x goes to negative infinity, that tells you to the left. So as x is going to positive infinity, the graph is going up. That means y is also going up, which is positive infinity. Now on the other side, as x is going to the left, the y value is still going up. So as y is going to as x is going to negative infinity, y is still going to positive infinity. This would tell you that the degree of this function is even. Okay? Now this next one, again, you start with as x goes to infinity. And on the left end, you have x is going to negative infinity. So where's this arrow going? It's going up. So as x is going to the right, y is going up, which tells you positive infinity. As x is going to the left, y is going down, which tells you negative infinity. Hopefully you got those both right. If you have any troubles, make sure you're asking about them. All right, so last couple examples I got for you. This is supposed to be a real-life situation. The graph shows the altitude of a drone above the ground, f of x, which is y, remember, after x minutes. Describe the end behavior of f of x and interpret it in the context of the situation. Now, so basically this is what we're doing. As x is increasing, so as x is going to positive infinity, what is the y value doing? Okay, the y value here is going up, which means y is also increasing, going to positive infinity. Now, in the context of this situation, you got to establish what these labels are telling you. Okay, so basically, as the time increases, what is happening to the altitude? Okay, so as time increases, the altitude increases. Now, I'm not going to worry about the other end because it wouldn't make sense for this graph to have negative time. To the left of this graph would be negative values, and negative minutes don't exist. We're always concerned with the starting point anytime we're dealing with time, and that starting point has to be 0. Okay, so I'm just going to X this part off. We don't need it. Now the next one. Mika and her friends are using a ride-sharing service to take them to a concert. The function models the cost of the ride f of x after x miles. Describe the end behavior of f of x and interpret it in the context. So, basically speaking, what's happening to x is it's going to positive infinity. It's going to the right. So as x is going to infinity, y, or f of x, is going to positive infinity as well. It's increasing. It's going up. Now, in context of the situation, as you drive more miles, as you ride more miles, the cost of the ride increases. Just like any other taxi or Uber or Lyft, you're charged per mile, and that's exactly how it works. You're going to be charged as you ride miles. Okay. Got a few more here. I'm just going to write the answers down so you have a couple extra examples. You're given the functions here, so I want to point this out since we actually are given the degree here. If you notice, the degree of this first one is 2, the second one is 3, third one is 4. If you have an even degree, and notice there's no negative out here to make it flip upside down. Kind of wish one of these was negative so I can show you. But the first one has an even degree and a positive leading coefficient. That means the graph is going to open up, so you're worried about the direction here. So as x is increasing, going to the right, y is going up, which means positive infinity. As x is going to the left, negative infinity, y is still going up, positive infinity. Next one, as x is going to the right, which is positive infinity, y is going up, which is, again, positive infinity. As x is going to the left side, negative infinity, y is going down in this case, okay? Again, whenever you have that odd degree, these are going to kind of flip directions like that. One's going to finish positive, one's going to finish negative. Now the last one, this is going to be the exact same thing as the first one. Because it's opening up, it has that even degree with a positive leading coefficient. X is going to positive infinity, x is going to negative infinity, and the graph is going up for both of them. So the y trend, the f of x trend, I'll write f of x this time, f of x is going to positive infinity for both end behaviors. And that's that. Okay? Your worksheet here, please pay attention to numbers 1 through 4. You're not always going to have an absolute max, an absolute min, a relative max, or a relative min. So you got to look for these. Notice there's a point here, but all of these points above that, so this is a relative max. So in that case, if it's going to infinity up, it's going to only be a relative max. There's not going to be an absolute max. Okay? Now on the other hand, down here, there's an absolute minimum, but there's no absolute maximum because both of these arrows are going up. Okay, so make sure you're paying attention to that. Give them a shot. I'll be going over answers in class, so you'll have the opportunity to ask any questions you have. Make sure you finish both sides of the worksheet. It's on both sides, and go from there. All right? If you have any questions, come find me or wait till class. Thanks.